Okay, hello everyone. We're going to go over this May 19 time zone 2 question, which is on Faraday's law. So we have a small magnet being dropped from rest, and it's going to fall through this conducting ring. South pole is upwards, north pole is downwards, so we know that the magnetic field is pointing in this direction, away from north. And the question is, why is the magnetic flux increasing? Well, of course, as the magnet comes closer, then the B field through the loop is going to increase in strength, and therefore the magnetic flux is going to be increasing. Okay, so as the magnet approaches the ring, the B field, B through the loop, increases in strength. Hence the flux increases. Okay. Sketch using an arrow on diagram to the direction. So we know that Lenz's law says that any induction effect opposes the change that caused it. So basically the wire does not want more and more B pointing through it from above. So the induced current is going to try and oppose that B field that is increasing downwards. So it's going to create its own B field going upwards to sort of to counter the incoming B field. And if you use your right hand rule, then you know that if the current flows in this counterclockwise direction, then you know we're going to get a B field going up out of the paper, inside the ring, and into the paper on the outside of the ring. And that's going to be the case all around the ring. So this is where the B field is pointing up through the ring. So it's opposing the increase in B field. Deduce the direction of the magnetic force. So the magnetic force is going to be upwards. And you can see that in many different ways. So one way is that, well, the ring sort of has a, the magnetic field, like I just said, is pointing upwards. So you basically have sort of two north poles that are repelling each other. So that's one way of saying it. Another way is that, well, since we suddenly have electrical energy in the circuit, then the magnet must have lost some kinetic energy, and energy is always conserved. So that's also the case, that the magnet had to then slow down. So there had to be an upwards force on it to exert some negative work on it. But okay, let's write the induced current creates a magnetic field pointing up through the loop. Hence, it will repel the incoming magnet by exerting an upwards force on it. There you go. Okay, just that one question.